All right, welcome everyone. So today we're going to talk about section 3.4, and this is how we're going to find the zeros for polynomials, especially of higher degree, like degree 3, degree 4, degree 5, etc. If it's a degree 2, we already have the quadratic formula, we have factoring, we have all kinds of things. So this is mostly for higher order polynomials. All right, so this theorem that we're going to learn today is called the rational root theorem or the rational zero theorem. And this will help us find rational zeros. There are other zeros to polynomials, like irrational ones. So let's make sure that we know the difference, okay? So irrational versus rational, right? Okay. So irrational is just, it's roots that are decimals that go on forever and don't repeat. So quite often that would be like a square root that's not a perfect square or something like that. Okay, so decimals that go on forever and don't repeat. I'm going to put specifically roots of non-perfect squares. So I'll put some examples so you know what I'm talking about. Okay. Whereas rational, right? So here's some examples, like square root of 7, square root of 3, okay? Things like that. All right, so this theorem above isn't going to help us find roots like that. This theorem above is going to help us find rational roots. Okay, so rational technically means a fraction, technically means a fraction or a decimal that terminates or repeats. Okay, so it's got a long list of things under it. Something like 7, that's a decimal that stops, 7.0, right? Okay, 3.2, technically, that's a decimal that stops. 0.333 forever, 1/3. All of these, negative 2/3, these would all be considered rational. So this theorem is going to help us find zeros like that, okay? So it won't help us find these square root type zeros. Okay, so let's talk about this theorem. This theorem says that if we have a polynomial and it has a rational zero, then it must be of the form P over Q, where P are factors of the last term and Q are factors of the first term. So let's use it and I'll explain, why this works in a second, okay? So to list all of the possible zeros. So remember, we have to put factors of the last, factors of last over factors of first. Oops. Okay, so what that means in this case, right? Okay, so the last number is negative 15. And the first number is 4. Oops. So we want factors of negative 15 on top of factors of 4. So all the things that multiply to make 15, right? Well, I know 1 times 15 and 3 times 5. So I'm just going to put those all on here. Okay, 1 times 15 and 3 times 5. And then all of the factors of 4, well, 1 times 4 and 2 times 2. And that's the only things that I can think of. Now, the plus or minus business, right? If I have negative 15, it could have been 3 times negative 5 that got me 15, or it could have been negative 3 times positive 5 that got me negative 15. So that's why I have to consider either a plus or minus 3, or maybe it's a plus or minus 5. Okay, I'm not sure. So that's why we're putting plus or minuses on them. Similarly for the bottom, right? Let's say we got positive 4. Well, it could have been negative 2 times negative 2 that got me positive 4, or it could have been positive 2 times positive 2 that got me positive 4. So we have to consider the plus or minus because that is indeed a factor. Okay, either one. All right. So once you've figured out all the factors with the plus or minuses on them, then you're just going to start stacking these, okay? And what I'm going to do is I'm just going to stack them all right now to make sure everybody understands what I'm doing. So I'm putting 1 on top of 1. I'm putting 1 on top of 2. I'm putting 1 on top of 4. So that was me stacking 1 on top of all the denominators. Now I'm going to stack 3 on top of 1, 3 on top of 2, and 3 on top of 4. So 3's been stacked on top of all of them. 5 on 1, 5 on 2, and 5 on 4. And then finally, 15 on 1, 15 on 2, and 15 on 4. All right, now you're going to go in here and you're going to reduce some of these, all of them, right? 1 divided by 1 is just 1. You can't do anything with 1/2. Can't do anything with 1/4. 3 divided by 1 is 3. Can't do anything with 3/2. Can't do anything with 3/4. 5 divided by 1 is 5. 5 over 2. 5 over 4. 15 divided by 1 is 15. 15 divided by 2 is still 15 over 2. And then 15 over 4. So this would be the list of possible rational zeros. Now we're going to figure out which ones actually are the zeros, but these are our possible ones. Okay, so that's the process. Now let's talk about the process, because when students take the test, instead of putting factors of the last over factors of the first, they always want to put factors of the first on top of factors of the last. So let's just kind of talk about why it ends up being last on top of first. Okay, so I'm going to go back. Okay, so let's consider the following polynomial. Okay, let's say that I have this and I'm trying to find the zeros of this. And let's pretend I haven't taught you like how to factor or the quadratic formula or anything like that. Then according to this formula, I would put factors of -21 on top of factors of 2. So all the things that multiply to make -21. So let's see, 1 times 21, 1 plus or minus 1, 3 times 7. Okay, so those are all the things that multiply to make 21, and all the things that multiply to make 2 is just 1 times 2. There's no other factors. So if I stack these, 1 divided by 1 is 1, 1 divided by 2 is 1/2, 3 divided by 1 is 3, 3 divided by 2 is 3/2. That's a 2, guys, sorry. And then 7 divided by 1 is 7, 7 divided by 2 is 7/2. And 21 divided by 1 is 21, and 21 divided by 2. Okay, now, what we're saying is these are all the possible zeros, okay? Now we're going to go in and we're going to get the actual zero so you can see why it becomes the last on top of the first, okay? So this factors in the following way. Okay, and don't worry about the details of that. You guys know how to factor, okay? So just trust me on that. So once we factor it, we set each piece equal to 0, right? Now, when you think about when you set each piece equal to 0, these back numbers, 7 and the 3, those back numbers, if you think about where they come from, those are factors of the last number, 21, okay? And then when you think about the beginning of the parentheses, the 2 and the 1, that was the factors of the front number. Now what happens when we solve is this back number gets moved over first, which means that that back number, when you follow all the math through, is going to be the one that ends up on top. Okay, so the back number of the parentheses ends up on top. Okay, so that's why we say the factors of the last number on top of factors of the first number. Same thing here, right? If we add the 7 over, plus 7, then we get 7, right? That's on top of really a 1, if you will. But this 7 is a factor of the back number, and the 1 is the factor of the front number, right? So because we always move the back first and divide by the front last, right? It's always going to be the last number that goes on the top and the first number that goes on the bottom. So hopefully that helped explain, why it's factors of the last over factors of the first. Now, you'll notice these numbers were on our list, right? -3/2 is contained within that, and +7 is inside of there. So this worked. We really did have a list that contained the zeros. Now, it doesn't say these are the zeros. It says the possible zeros, right? And so it really is correct and does indeed work. Okay. All right. So the next question is going to say, okay, take it a step further. You found the possible zeros, but now get the actual ones, right? Okay, so we'll start off by putting our factors of the last over factors of the first again. Okay, so factors of the last. Okay, so we need factors of 3, right? Well, 1 times 3 is the only way we're going to get 3, right? Love it when they're small prime numbers, or when they're prime numbers, right? Okay, so then factors of the first, so factors of 2. 1 times 2. I like this list. Okay, so our possible zeros, we got 1 divided by 1. We got 1 divided by 2. We got 3 divided by 1. We got 3 divided by 2. Okay, so those are our possible rational zeros. Now what we're going to do is we're going to check all of them individually by using synthetic division. Okay, so let's kind of write that out. Once you have your possible rational zeros, divide each one of them into the original polynomial using synthetic division. Whatever division you want, but synthetic's the easiest, right? Oops, division. Okay. If it has a remainder of 0, it's a 0. We know that from the last lesson that we had, right? Okay, so here we go, guys. We are going to take, let's just start off with one of them. So let's say we start off with 1. All righty, so notice all the exponents are here. 4, 3, 2, 1, none. So we got everybody, so we don't need any zeros. So I'm just going to write the coefficients in. And we're going to divide. All right, 1 times 2 is 2, add them together. 1 times 3 is 3, add together. 1 times -2 is -2, add together. And 1 times -3 is -3. What do you know? I'm usually not this lucky where I find it on the first try. Okay, so what we know from this is that -1 is a 0. -1 is a 0. I'm going to get a little squiggly bracket. I'll put -1 in there because we know that one so far. Now don't go back to the original polynomial, okay? Go to this new polynomial. So the new polynomial that we have, right, is down it by a degree. It was x to the 4th, so now it's x to the 3rd. 2x to the 3rd plus 3x to the 2nd minus 2x to the 1st minus 3. So that looks factorable. So I'm not going to continue doing this synthetic division thing. I'm going to try to factor by grouping on this, okay? All right, so I'm going to factor out an x squared, leaving me 2x plus 3. I'm going to factor out a -1 because I need all those signs to change, right? Now these match. So that's one of my parentheses. And the leftovers, x squared minus 1, are the others. Now that's a difference of squares, so I am going to take it to the next step and factor it. So it's x plus 1 and x minus 1. Remember that they're different signs, and you just square root these two numbers to figure out what you're going to put in the blanks, okay? All right, so when we set each piece equal to 0, I'm going to assume that you guys are like really good at this. This is going to be -3/2. This one's going to be -1, and this one's going to be +1. And notice those were all on the list. -3/2, yup. +1 and -1, yup. Okay. So our list has, let's go write them all in here now, right? -1, +1, and -3/2. Those are our zeros. Now they want the multiplicity, right? Well, remember, -1 showed up twice. It was a 0 up here, but it was also a 0 again. Okay, so that one's going to be multiplicity too. These two only showed up one time, so those are going to be multiplicity 1. Multiplicity 1. Okay, and that makes sense because let's count it out. 1, 2 for that one, 3, 4. And so we knew we should have 4 because our highest exponent is 4. So this is looking really good. I'm going to box this whole thing in. Okay. All right. Let's try another. Find the zeros in their multiplicity. Now notice this one does not factor by grouping. Let me just show you that so you guys can see. If I tried to take an x squared out, I get x minus 2. But then there's nothing that I can take out of this besides like a 1 or a -1. But it's never going to match x minus 2. So it looks like factor by grouping wouldn't work. So you know what to do. We're going to put factors of the last over factors of the first. Can't spell first. There we go. All right. So the last number is -5, right? So we're going to put factors of -5. So plus or minus 1, plus or minus 5. And the first number is just a 1. Yay for that. All right, so 1 divided by 1 is 1, and 5 divided by 1 is 5. So we only have 4 things to try. Cool. All right, so let's see here. I'm going to go ahead and put, let's try 1 inside the box. And then the coefficients, 1, -2, -14, and -5. Here we go. 1 times 1 is 1. Add downward. 1 times -1 is -1. Add downward. 1 times -15 is -15. This is not a remainder of 0. Okay, so let's try it again with -1. -1 times 1 is -1. Add downward. Negative times a negative equals a positive. Add downward. Negative times a negative equals a positive. That's not going to be 0 either. Okay, so let's try 5. Five times 1 is 5. 5 times 3 is 15. 5 times 1 is 5. Ding, 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 ding. Okay, so that one worked. Now the leftover polynomial, when all is said and done, will instead of degree 3, will now be degree 2. So x squared plus 3x plus 1 equals 0 is what we want to solve. Now don't keep trying synthetic division. Because it could very well be that the roots to this aren't even rational. So you do synthetic division and none of them work, right? So what we're going to do is we're going to do the quadratic formula to it. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. All right, so 3 squared is 9. Take away 4. 2 times 1 is 2. There it is, you guys. So to get the zeros in their multiplicities, here's our zeros. We got that 5 worked, right? And then we got -3 plus root 5 over 2 and -3 minus root 5 over 2. And the multiplicities for all of them were 1. And that makes sense. 1, 2, 3. And our highest exponent was 3. So we definitely don't want to be double counting anybody. They're all counted 1 time. Okay. So as soon as, what's the theme I want you guys to notice is, as soon as I got one of the zeros to work, I rewrote the polynomial and tried to use other methods. Okay, same thing over here, right? This 0 worked, and right away I rewrote the polynomial and factored. So you don't want to keep going just in case some of the zeros are irrational, or because we have faster ways like the quadratic formula and factoring. Okay, so we have these theorems that, you know, I'm trying to think about which ones we're going to use the most. We're definitely going to use these 2. We have been using these, at least the bottom one. The number of zeros is the same as the highest exponent, right? As long as you count the multiplicity. That's what we've been doing every time when we've said, okay, there's 1, 2, 3, and my highest exponent is 3. But you do have to count, sorry, you guys. Let me undo this really quickly. you do have to count the multiplicity, right? So on this one, if I just counted them and went 1, 2, 3, that wouldn't work because this one's exponent 4, right? So I have to remember to also count the multiplicity. So this one we counted 1, 2, because I have multiplicity 2, 3, 4. And so the highest exponent was 4. Okay. All right, so that's that theorem. The next theorem is really important. It says that the conjugate zeros theorem, if a plus bi is a 0, then a minus bi is a 0 also. If you think about it, there's no way for me to get like 3 plus 2i without getting 3 minus 2i, because quite often they would happen because of the quadratic formula, right? You'd have something like this from the quadratic formula, and you'd have to like clean it up and write it like this, right? And you'd notice that if I have 3 plus I root 2, I have 3 minus I root 2 because of the plus or minus. Or even in an instance where you're solving something like this, right? If I bring that 2 over to the other side and make them negative, right? Sorry, my square root. What do we have to remember every time we square root? We got to remember a plus or minus, right? So I'm not just going to get I root 2 without also getting negative I root 2. So moral of the story, if a plus bi is a root, then so is its conjugate pair, a minus bi. Okay. All right, so it says, given that 1 minus 5i is a 0, find the remaining zeros and factor as a product of linear factors. Okay, so right away on our list of zeros, which I always like to kind of have going, we already know 1 minus 5i is on it, which according to that new theorem means 1 plus 5i is on it as well. So we really only have one more zero to find, you guys, because it's a degree 3 polynomial. All right, so let's go in here and see what we can do to find it, okay? So we're going to do long synthetic division, and we know that 1 minus 5i works. It should have a remainder of 0 because they told me it's a 0. So I'm going to write in the coefficients. And we're going to divide, and we'll have remainder 0 if I do everything right. All right, 1 minus 5i times 1 is just 1 minus 5i. I'm going to combine these together because they're like terms. So that's going to get me negative 2 minus 5i. Now I have to multiply these two by each other. And I'm not smooth enough to do that in my head. So let me do that off to the side. All right, negative 2, negative 5i, positive 10i. And a negative times a negative is a positive 25i squared because of I times I. So we've got negative 2. These guys are going to make 5i. And don't forget, I squared is going to change this to a negative 25. So that's going to get us, when we combine these guys, negative 27 plus 5i. All right, let me write it right here. All right, and again, you're going to combine like terms. 28 minus 27 is just 1. And now we're going to multiply these by each other. Now remember, they are conjugates, you guys, so you don't have to do everything when you're doing the 1 minus 5i times the 1 plus 5i. It's enough to do the first and the last. I times I is I squared. Negative 25 will become positive 25 because the I squared will change its sign. And so we're going to get 26. Cool. That's when you know you did it right, right? We got remainder 0. Now, I'm going to do another round of synthetic division. Okay, so let's write that in here. We'll do another round. But we're going to do it with, we're not going to go back to the beginning, you guys. We're going to do another round with this. Okay, so you're going to have your 1, your negative 2 minus 5i, and your 1 plus 5i. And inside, you're going to put the conjugate because you know it's a 0 too, right? Remember we said 1 plus 5i is also a 0. All right, so don't go back to the beginning. Use this new one. All right, 1 times 1 plus 5i is 1 plus 5i. If we add downward, negative 2 plus 1 is negative 1, and the 5i's cancel with each other, right? So then we have negative 1 times 1 plus 5i. We'll just change the signs on those guys. Bada boom, bada bing. We got remainder 0. Now let's think about what degree this is going to be to. It was degree 3, but we divided once. So right here, it should be degree 2. Then we divided again. So right here, it should be degree 1. So this, if we turn it back into a polynomial, would just be 1x minus 1. We're going to set it equal to 0 and solve. So let's shoot that 1 over to the other side. And the 1, you guys, that's in front of it, you don't have to write it, right? That's just x. All right, so we found our last 0. Let's put them in there. All right. Now, that's going to be our zeros. So that's part of the directions. But then it says to write as a product of linear factors. Linear just means x to the first. So if I want to write f of x as a product of linear factors, that means I have to put these things back into the parentheses, right? Put the zeros back into the parentheses. So you know when you do that, you change the signs. So if it's a +1, then that means in the parentheses, it's going to be a -1. Oops. If it's I'm going to do this one first, you guys. So it's a +1, that means it's a -1. It's a -5i, that means it's a +5i. Do the same thing for the middle one now. It's a +1, okay, make it a -1. It's a +5i, make it a -5i. So this would be us writing f of x as a product of linear factors. Remember, linear factors means x to the firsts. There's not going to be any x squareds or anything. All right, so just change the signs on everything when you put them back into the parentheses. All right, given that x equals -1/2 is one solution, find the remaining solutions. Okay. All right, so we know -1/2 is going to go inside the box. We're going to do long division. Let's see, 4, 3, 2, 1, none. So we are good, no zeros. So I'm just going to write the coefficients, the numbers out front. And we know this is a solution, so we should get remainder 0. All right, negative times a positive is negative, and half of 2 is 1. Negative times a negative is a positive, and half of 2 is 1. Negative times a positive is negative, and half of 18 is 9. Negative times a negative is a positive, and half of 18 is 9. All right. So the remaining polynomial is going to be degree 3 now, because we always down it by 1. So this is going to be 2x cubed minus 2x squared plus 18x minus 18. And I know you're staring at that and you're saying, I'm definitely going to cut it down the middle and do factor by grouping. All right, so I'm going to take out a 2x squared, which will get me x minus 1. And I'm going to take out an 18, which will get me x minus 1. Oh, how perfect is that? All right, so x minus 1 is going to be one of them, and 2x squared plus 18 is the other. All right, so if we set each piece equal to 0, this one you guys can do in your head. This one's going to be the one where I'm not going to pretend I'm smooth. I'm going to like work it all out, you guys. Okay, so I'm going to move the 18 over, which will make the 18 a -18. Divide by 2, so x squared equals -9. Then I'm going to square root, and I'm not going to forget my plus or minus, right? So this is going to be plus or minus, oops. And don't forget, it is going to be I root 9, which means it's going to become plus or minus the square root of 9 is 3. Okay, so it says to find the remaining solutions. Okay, so the remaining solutions would be 1 and plus or minus 3i. All righty. Let's count them out. 1, 2, 3, and then don't forget -1/2. All right, so let's try number 6 here. It says find a polynomial of lowest degree with zeros of 3i and 2. All right, so this is that backwards thing again. You know, we talked about like what we did earlier today where we had some polynomial and we factored it. And then we, set each piece equal to 0. Okay. Well, we're doing that the other way, where I'm going to give you the zeros. You got to put them back into the parentheses. And then you got to FOIL them out to get the polynomial. Okay. So we kind of did that in the last section. Okay. So hopefully we're pretty good at it. Anyhow, here we go. So one of the things you got to know, though, is that if you got 3i as a 0, you also have negative 3i as a 0. And then we have x equals 2 with a multiplicity of 2. So we got to include it twice. So that means when we go back to our parentheses, you change the sign when you put them into the parentheses. And then negative 3i will become positive 3i. And then we're going to change the sign, x minus 2 times. Okay, then you're just going to go ahead and FOIL this guy out. And by the way, this is going to be called f of x when we get done, okay? So these are conjugates, so I only have to do the first and the last. So a negative times a positive is a negative. 3 times 3 is 9. I times I is I squared. I'm going to clean that guy up. He's going to end up being x squared plus 9, because I got to change the sign on that 9. And then over here, these aren't conjugates. One's not a plus and one a minus. We have to FOIL the whole thing out. So we're going to get x squared, negative 2x, negative 2x, and then positive 4. And we will clean up the middles. Negative 2x and negative 2x make negative 4x. All right, so nothing mind-blowing so far. You have to be really anal so that you don't make some small mistake here, because look at how much FOILing we're doing, right? So just double check yourself, go nice and slowly, because if you go fast, you're going to end up doing the problem twice. You know what I mean? So just go slowly, slow to actually go quick, if that makes sense, because you'll only do the problem one time. All right, negative 36 and positive 36. All right. All right, so we got x to the 4th minus 4x cubed plus 13x squared minus 36x plus 36. And we're going to call that our f of x. Okay, so what I want to do is I want to check it, because I trust myself very little when it comes to not making a mistake. So let's go in and at least see if this hits 2 twice. Okay, so this is what, GeoGebra. Okay, I'm going to type in the polynomial that we just said. So I think it was what, x to the 4th. That's all I remember, you guys. Minus 4x cubed plus 13x squared minus 4x cubed plus 13x squared, and then minus 36x plus 36 minus 36x plus 36. Look at that. Okay, it does have a 0 of 2, and since it's a touch and not a cross point, we do know that it's even multiplicity. So this looks great. Okay. On a side note, because this is going to segue into number 7, right? It says find a polynomial. It doesn't say find the polynomial, because there's actually infinitely many polynomials that could go through that point. We know from chapter 2 that if I put any number in front, it's just going to stretch it. So let's say I put a 2 in front and hit enter. It just made it a little skinnier. I could put a negative 2 and make it reflect over the x-axis, right? I mean, there's so many things that I could do here to still get the same zeros, though. Notice it's still going through 2, no matter what number I put out front. Put a 3, still going through 2, okay? So there could be any multiplier in the front, and it wouldn't affect the zeros that we're going to get. Okay, so that's going to segue into number 7. Find a polynomial of degree 3 with 0, negative 2i, and 4. So this is pretty much the same thing, you guys. There's just going to be one added extra step. Okay. All right, so let's see here. We know negative 2i is a 0, which means because conjugate pairs, that positive 2i is a 0. And then we got x equals 4. So we're going to change the signs when we put these guys back into the parentheses. And positive 4 will become negative 4. And we're just going to multiply this all out. So let's see, x squared minus 4i squared. We know that's going to become x squared plus 4. And that's going to multiply by this. I don't know why I put I squared, you guys. There's no I. X squared, right? All right, and then 4 times x is 4x. And 4 times negative 4 is negative 16. Now, don't put this down. This is not the polynomial that we want necessarily, okay? So there's this extra condition of it has to pass through 0, 32. Remember when we have f of x equals y, right? The stuff inside the parentheses is the x, and the stuff on the right-hand side is the y. So when somebody says p of 0 equals 32, you know that's the x, and you know that's the y. So this has to pass through 0, 32, okay? So what we're going to do is we're going to put a multiplier out front like we just talked about. Okay, it's not going to change the zeros of the polynomial, okay? And then this is p of x is what we're calling this guy. So what you're going to do is you're going to substitute 0 in for the x and 32 for the y, right? So remember y, p of x or f of x is y. So we're going to put the 32 here. And then we're going to plug 0 in for every single x. Which is nice, right? My favorite number to plug in, because all these are going to get annihilated. So the math that we have is 32 equals negative 16a. I'm going to divide by negative 16. And we get that a equals negative 2. Now, that is not our answer. Our final answer is putting that a back in front of the polynomial. So here's our final answer. We're going to go check it. We're going to go look at GeoGebra and make sure that this guy does what we want him to do. Now, I can't remember if like Connect Math makes you FOIL it out. I mean, this is a perfectly fine answer. It might make you distribute the negative 2. I don't know. But I mean, that's not hard for you guys to distribute. So either one of these would be acceptable to me. Let's go put this in, see if it works, okay? All right. So all I remember was the negative 2 part. Let me go check the rest out again. X cubed minus 4x squared. Oh, shoot. All right, negative 2. X cubed minus 4x squared plus 4x minus 16, I think. That's what I want to say it was. Why is it not like that? There we go. Oops. Okay, that's not even showing up, but it's probably because 0, 32 is a huge point, huh? All right, so let me shrink the axes so we can see 32. What's going on with my GeoGebra? Let me just copy all this. Oh, there we go. Okay, guys, it's not responding. So let me just reload. All right, take 2. I'm actually going to type in the point 0, 32. And then let me kind of shrink it so we can see the dang point, huh? So 32 is right there. All right. Now we can see what's going on. All right, negative 2, x to the third minus 4x to the second plus 4x minus 16 is what I think. Yes, look at that. So it went through the point, but it also went through x equals 4, which we said was our 0 that we're going to see. We're not going to see the imaginary numbers on the real number plane, but at least we could see the 4. And it did pass through that point. We don't have the negative 2 in front, right? So that 2 that we solved for, then it does go through 4, but it doesn't go through the point 0, 32. So it's really important that we have the negative 2 as a multiplier out front, you guys. All right, I think that does it for this section. All right, so good luck on the homework, guys. Take care.